Chapter 5, Example 8. Consider the fuel economy model again. N24-6. Sketch pictures as you answer the questions. What percent of cars get under 20 miles per gallon? Sketch the curve. Under 20 miles per gallon, we're going to put that horizontal line at 20 and sketch the left. There you go. So I want to find that area to the left of the curve. We know we can find this by z-score, so I'll do z equals 20 minus 24 over 6, which gives us a z-score of negative 0.67. We look in the table to find the probability that z is less than negative 0.67. So the probability that z is less than negative 0.67 is 0.2500. Before we write the final statement out, I want to show you how this works with technology. On the AP exam and on all the tests we take in class, you'll always have access to the calculator. As long as you state the model, sketch the curve properly, you can use the technology to come up with the answer. Don't start using that all the time and forget this process. You still need to know how to be able to do it by hand. But as we get to more complex problems, being able to use the technology to aid you will be a huge help. So we start at the home screen. Always start there. We're going to do a new document. I'm not going to save the old stuff. Hit no. Hit calculator page. Then we're going to do menu, statistics, stat calculations, and we want normal CDF, number 2. Our lower bound negative infinity, because we're going to the left, we put our upper bound, which is 20, our mean 24, our standard deviation 6, then hit OK. There you go, 0.252492. It's a little more exact than you get from the table, but that's it. Just follow those steps. Being able to find the area under a curve using technology is a good skill to have. According to the normal model, we would expect 25% of all cars to get under 20 miles per gallon. An ecology group is lobbying for a national goal calling for no more than 10% of all cars to be under 20 miles per gallon. If the standard deviation does not change, what average fuel efficiency must be attained? So we have our curve, sketch it out. I want to find what that x bar needs to be. So instead of putting a value, I'll put x bar. And somewhere to the left of that is 10%. So we want to find that area to the left of it. So really we just want to find that 10%. So when we look at the table, it's giving us all the area to the left of that. That will work for us. 10% equals 0.1000. So we're going to go to the table and find as close as we can get to 0.1000. Gives us a z-score of negative 1.28. Now we plug in all the information we know. Negative 1.28 equals 20 minus x bar over 6 because we want to be under 20 miles per gallon. Multiply by 6. And then subtract the 20. Then we're going to have a negative x bar, a negative 27.68. So we just cancel the negatives out. So x bar equals 27.68. It's got to be positive. If you get a negative, you know you did something wrong, or did not cancel out the negatives properly. According to the normal model, a mean mileage of 27.68 miles per gallon would be required to meet the new goal. Car manufacturers argue that they cannot raise the average that much. They believe they can only get 26 miles per gallon. What standard deviation would allow them to meet the only 10% under 20 miles per gallon goal? So now I have my curve of a mean of 26, I have 10% there, which will give us that same z-score. So negative 1.28 equals 20 minus 26 over s, because now I want to find the standard deviation. That's what the unknown is. So I multiply by s, negative 1.28s equals negative 6, divide by negative 1.28. So s equals 4.69. According to the normal model, a standard deviation of 4.69 miles per gallon with a mean of 26 miles per gallon would be required to meet the goal. Now this problem's an example of why you need to know how to use the formula and not depend on the technology for everything, because you can't put that information in and get a standard deviation out. There's not a menu that you can go through to find a standard deviation. You have to be able to set that up and then do the algebra to get to that point. Okay, so some things the calculator will really help you on, and some questions it can't do at all. What change in the fuel economy of cars would achieving that standard deviation bring about? What are the advantages and disadvantages? Lowering the standard deviation would mean more consistent fuel economy. This is advantageous because it helps meet the new goal. But it also means there would be fewer cars in the very high fuel economies, because it brings everything on both sides closer to the mean. So all fuel economies will be closer to that 24 miles per gallon. If you bring the lower end up, you have to bring the higher end down as well.